The Mysterious Island, by Jules Verne, Part 1, Chapter 13. "Well, Captain, where are we going to begin?" asked Pencroft next morning of the engineer. "At the beginning," replied Cyrus Harding. And in fact the settlers were compelled to begin at the very beginning. They did not possess even the tools necessary for making tools, and they were not even in the condition of nature, who, having time, husbands her strength. They had no time, since they had to provide for the immediate wants of their existence, and though, profiting by acquired experience, they had nothing to invent, still they had everything to make. Their iron and their steel were as yet only in the state of minerals, their earthenware in the state of clay, their linen and their clothes in the state of textile material. It must be said, however, that the settlers were men in the complete and higher sense of the word. The engineer Harding could not have been seconded by more intelligent companions, nor with more devotion and zeal. He had tried them, he knew their abilities. Gideon Spilett, a talented reporter, having learned everything so as to be able to speak of everything, would contribute largely with his head and hands to the colonization of the island. He would not draw back from any task. A determined sportsman, he would make a business of what till then had only been a pleasure to him. Herbert, a gallant boy, already remarkably well informed in the natural sciences, would render greater service to the common cause. Neb was devotion personified, clever, intelligent, indefatigable, robust, with iron health. He knew a little about the work of the forge, and could not fail to be very useful in the colony. As to Pencroft, he had sailed over every sea, a carpenter in the dockyards in Brooklyn, assistant tailor in the vessels of the state, gardener, cultivator during his holidays, etc., and like all seamen, fit for anything. He knew how to do everything. It would have been difficult to unite 5 men better fitted to struggle against fate, more certain to triumph over it. At the beginning, Cyrus Harding had said. Now this beginning of which the engineer spoke was the construction of an apparatus which would serve to transform the natural substances. The part which heat plays in these transformations is known. Now fuel, wood or coal, was ready for immediate use, and an oven must be built to use it. "What is this oven for?" asked Pencroft. "To make the pottery which we have need of," replied Harding. "And of what shall we make the oven?" "With bricks." "And the bricks?" "With clay. Let us start, my friends. To save trouble, we will establish our manufactory at the place of production. Neb will bring provisions, and there will be no lack of fire to cook the food." "No," replied the reporter, "but if there is a lack of food for want of instruments for the chase." "Ah, if only we had a knife!" cried the sailor. "Well?" asked Cyrus Harding. "Well, I would soon make a bow and arrows, and then there would be plenty of game in the larder." "Yes, a knife, a sharp blade," said the engineer, as if he was speaking to himself. At this moment his eyes fell upon Top, who was running about on the shore. Suddenly Harding's face became animated. "Top, here!" said he. The dog came at his master's call. The latter took Top's head between his hands, and unfastening the collar which the animal wore round his neck, he broke it in two, saying, "There are 2 knives, Pencroft." 2 hurrahs from the sailor was the reply. Top's collar was made of a thin piece of tempered steel. They had only to sharpen it on a piece of sandstone, then to raise the edge on a finer stone. Now sandstone was abundant on the beach, and 2 hours after, the stock of tools in the colony consisted of 2 sharp blades, which were easily fixed in solid handles. The production of these their first tools was hailed as a triumph. It was indeed a valuable result of their labor, and a very opportune one. They set out. Cyrus Harding proposed that they should return to the western shore of the lake, where the day before he had noticed the clayey ground of which he possessed a specimen. They therefore followed the bank of the Mersey, traversed Prospect Heights, and after a walk of 5 miles or more they reached a glade situated 200 feet from Lake Grant. On the way Herbert had discovered a tree, the branches of which the Indians of South America employ for making their bows. It was the crejimba, of the palm family, which does not bear edible fruit. Long straight branches were cut, the leaves stripped off. It was shaped, stronger in the middle, more slender at the extremities, and nothing remained to be done but to find a plant fit to make the bowstring. This was the hibiscus heterophyllus, which furnishes fibers of such remarkable tenacity that they have been compared to the tendons of animals. Pencroft thus obtained bows of tolerable strength, for which he only wanted arrows. These were easily made with straight, stiff branches, without knots, but the points with which they must be armed, that is to say, a substance to serve in lieu of iron, could not be met with so easily. But Pencroft said that having done his part of the work, chance would do the rest. The settlers arrived on the ground which had been discovered the day before. Being composed of the sort of clay which is used for making bricks and tiles, it was very useful for the work in question. There was no great difficulty in it. It was enough to scour the clay with sand, then to mold the bricks and bake them by the heat of a wood fire. Generally bricks are formed in molds, but the engineer contented himself with making them by hand. All that day and the day following were employed in this work. The clay, soaked in water, was mixed by the feet and hands of the manipulators, and then divided into pieces of equal size. A practiced workman can make, without a machine, about 10,000 bricks in 12 hours, but in their 2 days' work the 5 brickmakers on Lincoln Island had not made more than 3,000, which were ranged near each other until the time when their complete desiccation would permit them to be used in building the oven, that is to say, in 3 or 4 days. It was on the 2nd of April that Harding had employed himself in fixing the orientation of the island, or, in other words, the precise spot where the sun rose. The day before he had noted exactly the hour when the sun disappeared beneath the horizon, making allowance for the refraction. This morning he noted, no less exactly, the hour at which it reappeared. Between this setting and rising 12 hours 24 minutes passed. Then, 6 hours 12 minutes after its rising, the sun on this day would exactly pass the meridian, and the point of the sky which it occupied at this moment would be the north. At the said hour Cyrus marked this point, and putting in a line with the sun 2 trees which would serve him for marks, he thus obtained an invariable meridian for his ulterior operations. The settlers employed the 2 days before the oven was built in collecting fuel. Branches were cut all round the glade, and they picked up all the fallen wood under the trees. They were also able to hunt with greater success, since Pencroft now possessed some dozen arrows armed with sharp points. It was Top who had furnished these points by bringing in a porcupine, rather inferior eating, but of great value, thanks to the quills with which it bristled. These quills were fixed firmly at the ends of the arrows, the flight of which was made more certain by some cockatoo's feathers. The reporter and Herbert soon became very skilful archers. Game of all sorts, in consequence, abounded at the Chimneys: capybaras, pigeons, agoutis, grouse, etc. The greater part of these animals were killed in the part of the forest on the left bank of the Mercy, to which they gave the name of Jacamar Wood, in remembrance of the bird which Pencroft and Herbert had pursued when on their first exploration. This game was eaten fresh, but they preserved some capybara hams by smoking them above a fire of green wood, after having perfumed them with sweet-smelling leaves. However, this food, although very strengthening, was always roast upon roast, and the party would have been delighted to hear some soup bubbling on the hearth, but they must wait till a pot could be made, and consequently till the oven was built. During these excursions, which were not extended far from the brick-field, the hunters could discern the recent passage of animals of a large size, armed with powerful claws, but they could not recognize the species. Cyrus Harding advised them to be very careful, as the forest probably enclosed many dangerous beasts. And he did right. Indeed, Gideon Spilett and Herbert one day saw an animal which resembled a jaguar. Happily the creature did not attack them, or they might not have escaped without a severe wound. As soon as he could get a regular weapon, that is to say, one of the guns which Pencroft begged for, Gideon Spilett resolved to make desperate war against the ferocious beasts, and exterminate them from the island. The chimneys during these few days were not made more comfortable, for the engineer hoped to discover, or build if necessary, a more convenient dwelling. They contented themselves with spreading moss and dry leaves on the sand of the passages, and on these primitive couches the tired workers slept soundly. They also reckoned the days they had passed on Lincoln Island, and from that time kept a regular account. The 5th of April, which was Wednesday, was 12 days from the time when the wind threw the castaways on this shore. On the 6th of April, at daybreak, the engineer and his companions were collected in the glade, at the place where they were going to perform the operation of baking the bricks. Naturally, this had to be in the open air, and not in a kiln, or rather, the agglomeration of bricks made an enormous kiln which would bake itself. The fuel, made of well-prepared faggots, was laid on the ground and surrounded with several rows of dried bricks, which soon formed an enormous cube, to the exterior of which they contrived air-holes. The work lasted all day, and it was not till the evening that they set fire to the faggots. No one slept that night, all watching carefully to keep up the fire. The operation lasted 48 hours, and succeeded perfectly. It then became necessary to leave the smoking mass to cool, and during this time Neb and Pencroft, guided by Cyrus Harding, brought, on a hurdle made of interlaced branches, loads of carbonate of lime and common stones, which were very abundant, to the north of the lake. These stones, when decomposed by heat, made a very strong quicklime, greatly increased by slacking, at least as pure as if it had been produced by the calcination of chalk or marble. Mixed with sand, the lime made excellent mortar. The result of these different works was that on the 9th of April the engineer had at his disposal a quantity of prepared lime and some thousands of bricks. Without losing an instant, therefore, they began the construction of a kiln to bake the pottery, which was indispensable for their domestic use. They succeeded without much difficulty. 5 days after, the kiln was supplied with coal, which the engineer had discovered lying open to the sky towards the mouth of the Red Creek, and the first smoke escaped from a chimney 20 feet high. The glade was transformed into a manufactory, and Pencroft was not far wrong in believing that from this kiln would issue all the products of modern industry. In the meantime, what the settlers first manufactured was a common pottery in which to cook their food. The chief material was clay, to which Harding added a little lime and quartz. This paste made regular pipe clay, with which they manufactured bowls, cups molded on stones of a proper size, great jars, and pots to hold water, etc. The shape of these objects was clumsy and defective, but after they had been baked at a high temperature, the kitchen of the chimneys was provided with a number of utensils, as precious to the settlers as the most beautifully enameled china. We must mention here that Pencroft, desirous to know if the clay thus prepared was worthy of its name of pipe clay, made some large pipes, which he thought charming, but for which, alas, he had no tobacco, and that was a great privation to Pencroft. "But tobacco will come like everything else," he repeated, in a burst of absolute confidence. This work lasted till the 15th of April, and the time was well employed. The settlers, having become potters, made nothing but pottery. When it suited Cyrus Harding to change them into smiths, they would become smiths. But the next day being Sunday, and also Easter Sunday, all agreed to sanctify the day by rest. These Americans were religious men, scrupulous observers of the precepts of the Bible, and their situation could not but develop sentiments of confidence towards the Author of all things. On the evening of the 15th of April they returned to the Chimneys, carrying with them the pottery, the furnace being extinguished until they could put it to a new use. Their return was marked by a fortunate incident. The engineer discovered a substance which replaced tinder. It is known that a spongy, velvety flesh is procured from a certain mushroom of the genus Polyporus. Properly prepared, it is extremely inflammable, especially when it has previously been saturated with gunpowder or boiled in a solution of nitrate or chlorate of potash. But till then they had not found any of these polypores, or even any of the morels which could replace them. On this day the engineer, seeing a plant belonging to the wormwood genus, the principal species of which are absinthe, balm mint, tarragon, etc., gathered several tufts, and presenting them to the sailor, said, "Here, Pencroft, this will please you." Pencroft looked attentively at the plant, covered with long silky hair, the leaves being clothed with soft down. "What's that, captain?" asked Pencroft. "Is it tobacco?" "No," replied Harding. "It is wormwood. Chinese wormwood to the learned, but to us it will be tinder." When the wormwood was properly dried, it provided them with a very inflammable substance, especially afterwards when the engineer had impregnated it with nitrate of potash, of which the island possessed several beds, and which is, in truth, saltpeter. The colonists had a good supper that evening. Ned prepared some agouti soup, a smoked capybara ham, to which was added the boiled tubercules of the Caladium mycorrhizum, an herbaceous plant of the arum family. They had an excellent taste, and were very nutritious, being something similar to the substance which is sold in England under the name of Portland sago. They were also a good substitute for bread, which the settlers in Lincoln Island did not yet possess. When supper was finished, before sleeping, Harding and his companions went to take the air on the beach. It was 8 o'clock in the evening. The night was magnificent. The moon, which had been full 5 days before, had not yet risen, but the horizon was already silvered by those soft, pale shades which might be called the dawn of the moon. At the southern zenith glittered the circumpolar constellations, and above all the Southern Cross, which some days before the engineer had greeted on the summit of Mount Franklin. Cyrus Harding gazed for some time at this splendid constellation, which has at its summit and at its base 2 stars of the first magnitude, at its left arm a star of the second, and at its right arm a star of the third magnitude. Then, after some minutes' thought, "Herbert," he asked of the lad, "is not this the 15th of April?" "Yes, captain," replied Herbert. "Well, if I am not mistaken, tomorrow will be one of the 4 days in the year in which the real time is identical with average time. That is to say, my boy, that tomorrow, to within some seconds, the sun will pass the meridian just at midday by the clocks. If the weather is fine, I think that I shall obtain the longitude of the island with an approximation of some degrees." "Without instruments? Without a sextant?" asked Gideon Spilett. "Yes," replied the engineer. "Also, since the night is clear, I will try this very evening to obtain our latitude by calculating the height of the Southern Cross, that is, from the southern pole above the horizon. You understand, my friends, that before undertaking the work of installation in earnest it is not enough to have found out that this land is an island. We must, as nearly as possible, know at what distance it is situated, either from the American continent or Australia, or from the principal archipelagos of the Pacific." "In fact," said the reporter, "instead of building a house, it would be more important to build a boat, if by chance we are not more than 100 miles from an inhabited coast." "That is why," returned Harding, I am going to try this evening to calculate the latitude of Lincoln Island, and tomorrow at midday I will try to calculate the longitude." If the engineer had possessed a sextant, an apparatus with which the angular distance of objects can be measured with great precision, there would have been no difficulty in the operation. This evening by the height of the pole, the next day by the passing of the sun at the meridian, he would obtain the position of the island. But as they had not one, he would have to supply the deficiency. Harding then entered the Chimneys. By the light of the fire he cut 2 little flat rulers, which he joined together at one end, so as to form a pair of compasses, whose legs could separate or come together. The fastening was fixed with a strong acacia thorn which was found in the woodpile. This instrument finished, the engineer returned to the beach, but as it was necessary to take the height of the pole from above a clear horizon, that is, a sea horizon, and as Claw Cape hid the southern horizon, he was obliged to look for a more suitable station. The best would evidently have been the shore exposed directly to the south, but the Mersey would have to be crossed, and that was a difficulty. Harding resolved in consequence to make his observation from Prospect Heights, taking into consideration its height above the level of the sea, a height which he intended to calculate next day by a simple process of elementary geometry. The settlers, therefore, went to the plateau, ascending the left bank of the Mersey, and placed themselves on the edge which looked northwest and southeast, that is, above the curiously shaped rocks which bordered the river. This part of the plateau commanded the heights of the left bank, which sloped away to the extremity of Claw Cape and to the southern side of the island. No obstacle intercepted their gaze, which swept the horizon in a semicircle from the cape to Reptile End. To the south the horizon, lighted by the first rays of the moon, was very clearly defined against the sky. At this moment the Southern Cross presented itself to the observer in an inverted position, the star Alpha marking its base, which is nearer to the southern pole. This constellation is not situated as near to the Antarctic pole as the polar star is to the Arctic pole. The star Alpha is about 27 degrees from it, but Cyrus Harding knew this and made allowance for it in his calculation. He then took care also to observe the moment when it passed the meridian below the pole, which would simplify the operation. Cyrus Harding pointed one leg of the compasses to the horizon, the other to Alpha, and the space between the 2 legs gave him the angular distance which separated Alpha from the horizon. In order to fix the angle obtained, he fastened with thorns the 2 pieces of wood on a third placed transversely, so that their separation should be properly maintained. That done, there was only the angle to calculate by bringing back the observation to the level of the sea, taking into consideration the depression of the horizon, which would necessitate measuring the height of the cliff. The value of this angle would give the height of Alpha, and consequently that of the pole above the horizon, that is to say, the latitude of the island, since the latitude of a point of the globe is always equal to the height of the pole above the horizon of this point. The calculations were left for the next day, and at 10 o'clock everyone was sleeping soundly. End of chapter. The Mysterious Island by Jules Verne. Part 1, Chapter 14. The next day, the 16th of April, and Easter Sunday, the settlers issued from the Chimneys at daybreak, and proceeded to wash their linen. The engineer intended to manufacture soap as soon as he could procure the necessary materials, soda or potash, fat or oil. The important question of renewing their wardrobe would be treated of in the proper time and place. At any rate, their clothes would last at least 6 months longer, for they were strong, and could resist the wear of manual labor. But all would depend on the situation of the island with regard to inhabited land. This would be settled today, if the weather permitted. The sun rising above a clear horizon announced a magnificent day, one of those beautiful autumn days which are like the last farewells of the warm season. It was now necessary to complete the observations of the evening before, by measuring the height of the cliff above the level of the sea. "Shall you not need an instrument similar to the one which you used yesterday?" said Herbert to the engineer. "No, my boy," replied the latter. "We are going to proceed differently, but in as precise a way." Herbert, wishing to learn everything he could, followed the engineer to the beach. Pencroft, Neb, and the reporter remained behind and occupied themselves in different ways. Cyrus Harding had provided himself with a straight stick, 12 feet long, which he had measured as exactly as possible by comparing it with his own height, which he knew to a hair. Herbert carried a plumb line which Harding had given him, that is to say, a simple stone fastened to the end of a flexible fiber. Having reached a spot about 20 feet from the edge of the beach, and nearly 500 feet from the cliff, which rose perpendicularly, Harding thrust the pole 2 feet into the sand, and wedging it up carefully, he managed, by means of the plumb line, to erect it perpendicularly with the plane of the horizon. That done, he retired the necessary distance, when, lying on the sand, his eye glanced at the same time at the top of the pole and the crest of the cliff. He carefully marked the place with a little stick. Then, addressing Herbert, "Do you know the first principles of geometry?" he asked. "Slightly, captain," replied Herbert, who did not wish to put himself forward. "You remember what are the properties of two similar triangles?" "Yes," replied Herbert. "Their homologous sides are proportional." "Well, my boy, I have just constructed two similar right-angled triangles. The first, the smallest, has for its sides the perpendicular pole, the distance which separates the little stick from the foot of the pole, and my visual ray for hypotenuse. The second has for its sides the perpendicular cliff, the height of which we wish to measure, the distance which separates the little stick from the bottom of the cliff, and my visual ray also forms its hypotenuse, which proves to be prolongation of that of the first triangle." "Ah, captain, I understand!" cried Herbert. "As the distance from the stick to the pole is to this distance from the stick to the base of the cliff, so is the height of the pole to the height of the cliff." "Just so, Herbert," replied the engineer. "And when we have measured the first two distances, knowing the height of the pole, we shall only have a sum in proportion to do, which will give us the height of the cliff, and will save us the trouble of measuring it directly." The two horizontal distances were found out by means of the pole, whose length above the sand was exactly 10 feet. The first distance was 15 feet between the stick and the place where the pole was thrust into the sand. The second distance between the stick and the bottom of the cliff was 500 feet. These measurements finished, Cyrus Harding and the lad returned to the Chimneys. The engineer then took a flat stone which he had brought back from one of his previous excursions, a sort of slate on which it was easy to trace figures with a sharp shell. He then proved the following proportions: 15 is to 500 as 10 is to x. 500 times 10 equals 5,000. 5,000 divided by 15 equals 333.3. From which it was proved that the granite cliff measured 333 feet in height. Cyrus Harding then took the instrument which he had made the evening before, the space between its two legs giving the angular distance between the star Alpha and the horizon. He measured, very exactly, the opening of this angle on a circumference which he divided into 360 equal parts. Now this angle, by adding to it the 27 degrees which separated Alpha from the Antarctic pole, and by reducing to the level of the sea the height of the cliff on which the observation had been made, was found to be 53 degrees. These 53 degrees being subtracted from 90 degrees, the distance from the pole to the equator, there remained 37 degrees. Cyrus Harding concluded, therefore, that Lincoln Island was situated on the 37th degree of the southern latitude, or, taking into consideration through the imperfection of the performance an error of 5 degrees, that it must be situated between the 35th and the 40th parallel. There was only the longitude to be obtained, and the position of the island would be determined. The engineer hoped to attempt this the same day at 12 o'clock, at which moment the sun would pass the meridian. It was decided that Sunday should be spent in a walk, or rather an exploring expedition, to that side of the island between the north of the lake and Shark Gulf, and if there was time they would push their discoveries to the northern side of Cape South Mandible. They would breakfast on the downs and not return till evening. At 8:30 the little band was following the edge of the channel. On the other side, on Safety Islet, numerous birds were gravely strutting. They were divers, easily recognized by their cry, which much resembles the braying of a donkey. Pencroft only considered them in an eatable point of view, and learnt with some satisfaction that their flesh, though blackish, is not bad food. Great amphibious creatures could also be seen crawling on the sand, seals doubtless, who appeared to have chosen the islet for a place of refuge. It was impossible to think of those animals in an alimentary point of view, for their oily flesh is detestable. However, Cyrus Harding observed them attentively, and without making known his idea, he announced to his companions that very soon they would pay a visit to the islet. The beach was strewn with innumerable shells, some of which would have rejoiced the heart of a conchologist. There were, among others, the Phasianella, the Terebratula, etc. But what would be of more use was the discovery, by Neb, at low tide, of a large oyster bed among the rocks, nearly 5 miles from the Chimneys. "Neb will not have lost his day," cried Pencroft, looking at the spacious oyster bed. "It is really a fortunate discovery," said the reporter, "and as it is said that each oyster produces yearly from 50 to 60,000 eggs, we shall have an inexhaustible supply there." "Only I believe that the oyster is not very nourishing," said Herbert. "No," replied Harding, "the oyster contains very little nitrogen, and if a man lived exclusively on them, he would have to eat not less than 15 to 16 dozen a day." "Capital!" replied Pencroft. "We might swallow dozens and dozens without exhausting the bed. Shall we take some for breakfast?" And without waiting for a reply to this proposal, knowing that it would be approved of, the sailor and Neb detached a quantity of the mollusks. They put them in a sort of net of hibiscus fiber, which Neb had manufactured, and which already contained food. They then continued to climb the coast between the downs and the sea. From time to time Harding consulted his watch, so as to be prepared in time for the solar observation, which had to be made exactly at midday. All that part of the island was very barren as far as the point which closed Union Bay, and which had received the name of Cape South Mandible. Nothing could be seen there but sand and shells, mingled with debris of lava. A few sea-birds frequented this desolate coast, gulls, great albatrosses, as well as wild duck, for which Pencroft had a great fancy. He tried to knock some over with an arrow, but without result, for they seldom perched, and he could not hit them on the wing. This led the sailor to repeat to the engineer, "You see, Captain, so long as we have not 1 or 2 fowling pieces, we shall never get anything." "Doubtless, Pencroft," replied the reporter, "but it depends on you. Procure us some iron for the barrels, steel for the hammers, saltpeter, coal, and sulphur for powder, mercury and nitric acid for the fulminate, and lead for the shot, and the captain will make us first-rate guns." "Oh," replied the engineer, "we might, no doubt, find all these substances on the island, but a gun is a delicate instrument, and needs very particular tools. However, we shall see later." "Why," cried Pencroft, "were we obliged to throw overboard all the weapons we had with us in the car, all our implements, even our pocket knives?" "But if we'd not thrown them away, Pencroft, the balloon would have thrown us to the bottom of the sea," said Herbert. "What you say is true, my boy," replied the sailor. Then, passing to another idea, "Think," said he, "how astounded Jonathan Forster and his companions must have been when, next morning, they found the place empty and the machine flown away." "I am utterly indifferent about knowing what they may have thought," said the reporter. "It was all my idea, that," said Pencroft, with a satisfied air. "A splendid idea, Pencroft," replied Gideon Spilett, laughing, "and which has placed us where we are." "I would rather be here than in the hands of the Southerners," cried the sailor, "especially since the captain has been kind enough to come and join us again." "So would I, truly," replied the reporter. "Besides, what do we want? Nothing." "If that is not everything," replied Pencroft, laughing and shrugging his shoulders. "But some day or other we shall find means of going away." "Sooner, perhaps, than you imagine, my friends," remarked the engineer, "if Lincoln Island is but a medium distance from an inhabited island or from a continent. We shall know in an hour. I have not a map of the Pacific, but my memory has preserved a very clear recollection of its southern part. The latitude which I obtained yesterday placed New Zealand to the west of Lincoln Island, and the coast of Chile to the east. But between these two countries there is a distance of at least 6,000 miles. It has therefore to be determined what point in this great space the island occupies, and this the longitude will give us presently, with a sufficient approximation, I hope." "Is not the archipelago of the Pomotus the nearest point to us in latitude?" asked Herbert. "Yes," replied the engineer, "but the distance which separates us from it is more than 1,200 miles." "And that way?" asked Neb, who followed the conversation with extreme interest, pointing to the south. "That way, nothing," replied Pencroft. "Nothing indeed," added the engineer. "Well, Cyrus," asked the reporter, "if Lincoln Island is not more than 2,000 or 3,000 miles from New Zealand or Chile?" "Well," replied the engineer, "instead of building a house we will build a boat, and Master Pencroft shall be put in command." "Well, then," cried the sailor, "I am quite ready to be captain, as soon as you can make a craft that's able to keep at sea." "We shall do it, if it is necessary," replied Cyrus Harding. But while these men, who really hesitated at nothing, were talking, the hour approached at which the observation was to be made. What Cyrus Harding was to do to ascertain the passage of the sun at the meridian of the island, without an instrument of any sort, Herbert could not guess. The observers were then about 6 miles from the Chimneys, not far from that part of the downs in which the engineer had been found after his enigmatical preservation. They halted at this place and prepared for breakfast, for it was 11:30. Herbert went for some fresh water from a stream which ran near, and brought it back in a jug, which Neb had provided. During these preparations Harding arranged everything for his astronomical observation. He chose a clear place on the shore, which the ebbing tide had left perfectly level. This bed of fine sand was as smooth as ice, not a grain out of place. It was of little importance whether it was horizontal or not, and it did not matter much whether the stick, 6 feet high, which was planted there, rose perpendicularly. On the contrary, the engineer inclined it towards the south, that is to say, in the direction of the coast opposite to the sun, for it must not be forgotten that the settlers in Lincoln Island, as the island was situated in the southern hemisphere, saw the radiant planet describe its diurnal arc above the northern and not above the southern horizon. Herbert now understood how the engineer was going to proceed to ascertain the culmination of the sun, that is to say, its passing the meridian of the island, or in other words, determining due south. It was by means of the shadow cast on the sand by the stick, a way which, for want of an instrument, would give him a suitable approach to the result which he wished to obtain. In fact, the moment when this shadow would reach its minimum of length would be exactly 12 o'clock, and it would be enough to watch the extremity of the shadow, so as to ascertain the instant when, after having successively diminished, it began to lengthen. By inclining his stick to the side opposite to the sun, Cyrus Harding made the shadow longer, and consequently its modifications would be more easily ascertained. In fact, the longer the needle of a dial is, the more easily can the movement of its point be followed. The shadow of the stick was nothing but the needle of a dial. The moment had come, and Cyrus Harding knelt on the sand, and with little wooden pegs, which he stuck into the sand, he began to mark the successive diminutions of the stick's shadow. His companions, bending over him, watched the operation with extreme interest. The reporter held his chronometer in his hand, ready to tell the hour which it marked when the shadow would be at its shortest. Moreover, as Cyrus Harding was working on the 16th of April, the day on which the true and the average time are identical, the hour given by Gideon Spilett would be the true hour then at Washington, which would simplify the calculation. Meanwhile, as the sun slowly advanced, the shadow slowly diminished, and when it appeared to Cyrus Harding that it was beginning to increase, he asked, "What o'clock is it?" 1 minute past 5, replied Gideon Spilett directly. They had now only to calculate the operation. Nothing could be easier. It could be seen that there existed, in round numbers, a distance of 5 hours between the meridian of Washington and that of Lincoln Island. That is to say, it was midday in Lincoln Island when it was already 5 o'clock in the evening in Washington. Now the sun, in its apparent movement round the earth, traverses 1 degree in 4 minutes, or 15 degrees an hour. 15 degrees multiplied by 5 hours gives 75 degrees. Then, since Washington is 77 degrees 3 minutes 11 seconds, as much as to say 77 degrees counted from the meridian of Greenwich, which the Americans take for their starting point for longitudes concurrently with the English, it followed that the island must be situated 77 and 75 degrees west of the meridian of Greenwich, that is to say, on the 152nd degree of west longitude. Cyrus Harding announced this result to his companions, and taking into consideration errors of observation, as he had done for the latitude, he believed he could positively affirm that the position of Lincoln Island was between the 35th and the 37th parallel, and between the 150th and the 155th meridian to the west of the meridian of Greenwich. The possible fault which he attributed to errors in the observation was, it may be seen, of 5 degrees on both sides, which, at 60 miles to a degree, would give an error of 300 miles in latitude and longitude for the exact position. But this error would not influence the determination which it was necessary to take. It was very evident that Lincoln Island was at such a distance from every country or island that it would be too hazardous to attempt to reach one in a frail boat. In fact, this calculation placed it at least 1,200 miles from Tahiti and the islands of the archipelago of the Pomotus, more than 1,800 miles from New Zealand, and more than 4,500 miles from the American coast. And when Cyrus Harding consulted his memory, he could not remember in any way that such an island occupied, in that part of the Pacific, the situation assigned to Lincoln Island. End of chapter. The Mysterious Island by Jules Verne, Part 1, Chapter 15. The next day, the 17th of April, the sailor's first words were addressed to Gideon Spilett. "Well, sir," he asked, "what shall we do today?" "What the captain pleases." replied the reporter. Till then the engineer's companions had been brickmakers and potters. Now they were to become metallurgists. The day before, after breakfast, they had explored as far as the point of Mandible Cape, 7 miles distant from the Chimneys. There the long series of downs ended, and the soil had a volcanic appearance. There were no longer high cliffs as at Prospect Heights, but a strange and capricious border which surrounded the narrow gulf between the two capes, formed of mineral matter thrown up by the volcano. Arrived at this point, the settlers retraced their steps, and at nightfall entered the Chimneys, but they did not sleep before the question of knowing whether they could think of leaving Lincoln Island or not was definitely settled. The 1,200 miles which separated the island from the Pomotus Island was a considerable distance. A boat could not cross it, especially at the approach of the bad season. Pencroft had expressly declared this. Now, to construct a simple boat, even with the necessary tools, was a difficult work, and the colonists not having tools, they must begin by making hammers, axes, adzes, saws, augers, planes, etc., which would take some time. It was decided, therefore, that they would winter at Lincoln Island, and that they would look for a more comfortable dwelling than the Chimneys, in which to pass the winter months. Before anything else could be done, it was necessary to make the iron ore, of which the engineer had observed some traces in the northwest part of the island, fit for use by converting it either into iron or into steel. Metals are not generally found in the ground in a pure state. For the most part they are combined with oxygen or sulfur. Such was the case with the 2 specimens which Cyrus Harding had brought back, one of magnetic iron, not carbonated, the other a pyrite, also called sulphuret of iron. It was therefore the first, the oxide of iron, which they must reduce with coal, that is to say, get rid of the oxygen, to obtain it in a pure state. This reduction is made by subjecting the ore with coal to a high temperature, either by the rapid and easy Catalan method, which has the advantage of transforming the ore into iron in a single operation, or by the blast furnace, which first smelts the ore, then changes it into iron, by carrying away the 3 to 4% of coal which is combined with it. Now Cyrus Harding wanted iron, and he wanted to obtain it as soon as possible. The ore which he had picked up was in itself very pure and rich. It was the oxygenous iron, which is found in confused masses of a deep gray color. It gives a black dust, crystallized in the form of the regular octahedron. Native lodestones consist of this ore, and iron of the first quality is made in Europe from that with which Sweden and Norway are so abundantly supplied. Not far from this vein was the vein of coal already made use of by the settlers. The ingredients for the manufacture being close together would greatly facilitate the treatment of the ore. This is the cause of the wealth of the mines in Great Britain, where the coal aids the manufacture of the metal extracted from the same soil at the same time as itself. "Then, Captain," said Pencroft, "we are going to work iron ore?" "Yes, my friend," replied the engineer, "and for that, something which will please you, we must begin by having a seal hunt on the islet." "A seal hunt!" cried the sailor, turning towards Gideon Spilett. "Are seals needed to make iron?" "Since Cyrus has said so," replied the reporter. But the engineer had already left the Chimneys, and Pencroft prepared for the seal hunt, without having received any other explanation. Cyrus Harding, Herbert, Gideon Spilett, Neb, and the sailor were soon collected on the shore, at a place where the channel left a ford passable at low tide. The hunters could therefore traverse it without getting wet higher than the knee. Harding then put his foot on the islet for the first, and his companions for the second time. On their landing some hundreds of penguins looked fearlessly at them. The hunters, armed with sticks, could have killed them easily, but they were not guilty of such useless massacre, as it was important not to frighten the seals, who were lying on the sand several cable lengths off. They also respected certain innocent-looking birds, whose wings were reduced to the state of stumps, spread out like fins, ornamented with feathers of a scaly appearance. The settlers therefore prudently advanced towards the north point, walking over ground riddled with little holes, which formed nests for the sea-birds. Towards the extremity of the islet appeared great black heads floating just above the water, having exactly the appearance of rocks in motion. These were the seals which were to be captured. It was necessary, however, first to allow them to land, for with their close short hair and their fusiform conformation, being excellent swimmers, it is difficult to catch them in the sea, while on land their short webbed feet prevent their having more than a slow waddling movement. Pencroft knew the habits of these creatures, and he advised waiting till they were stretched on the sand, when the sun before long would send them to sleep. They must then manage to cut off their retreat and knock them on the head. The hunters, having concealed themselves behind the rocks, waited silently. An hour passed before the seals came to play on the sand. They could count half a dozen. Pencroft and Herbert then went round the point of the islet, so as to take them in the rear and cut off their retreat. During this time, Cyrus Harding, Spilett, and Neb, crawling behind the rocks, glided toward the future scene of combat. All at once, the tall figure of the sailor appeared. Pencroft shouted. The engineer and his two companions threw themselves between the sea and the seals. Two of the animals soon lay dead on the sand, but the rest regained the sea in safety. "Here are the seals required, Captain," said the sailor, advancing towards the engineer. "Capital," replied Harding. "We will make bellows of them." "Bellows!" cried Pencroft. "Well, these are lucky seals." It was, in fact, a blowing machine, necessary for the treatment of the ore that the engineer wished to manufacture with the skins of the amphibious creatures. They were of a medium size, for their length did not exceed 6 feet. They resembled a dog about the head. As it was useless to burden themselves with the weight of both the animals, Neb and Pencroft resolved to skin them on the spot, while Cyrus Harding and the reporter continued to explore the islet. The sailor and the negro cleverly performed the operation, and 3 hours afterwards Cyrus Harding had at his disposal 2 seal skins, which he intended to use in this state without subjecting them to any tanning process. The settlers waited till the tide was again low, and crossing the channel they entered the Chimneys. The skins had then to be stretched on a frame of wood and sewn by means of fibers, so as to preserve the air without allowing too much to escape. Cyrus Harding had nothing but the 2 steel blades from Top's collar, and yet he was so clever, and his companions aided him with so much intelligence, that 3 days afterwards the little colony's stock of tools was augmented by a blowing machine, destined to inject the air into the midst of the ore when it should be subjected to heat, an indispensable condition to the success of the operation. On the morning of the 20th of April began the metallic period, as the reporter called it in his notes. The engineer had decided, as has been said, to operate near the veins both of coal and ore. Now, according to his observations, these veins were situated at the foot of the northeast spurs of Mount Franklin, that is to say, a distance of 6 miles from their home. It was impossible, therefore, to return every day to the Chimneys, and it was agreed that the little colony should camp under a hut of branches, so that the important operation could be followed night and day. This settled, they set out in the morning. Neb and Pencroft dragged the bellows on a hurdle, also a quantity of vegetables and animals, which they besides could renew on the way. The road led through Jacamar Wood, which they traversed obliquely from southeast to northwest, and in the thickest part. It was necessary to beat a path, which would in the future form the most direct road to Prospect Heights and Mount Franklin. The trees, belonging to the species already discovered, were magnificent. Herbert found some new ones, among others some which Pencroft called shamleeks, for in spite of their size they were of the same liliaceous family as the onion, chive, shallot, or asparagus. These trees produce ligneous roots, which, when cooked, are excellent. From them, by fermentation, a very agreeable liquor is made. They therefore made a good store of the roots. The journey through the wood was long. It lasted the whole day, and so allowed plenty of time for examining the flora and fauna. Top, who took special charge of the fauna, ran through the grass and brushwood, putting up all sorts of game. Herbert and Gideon Spilett killed 2 kangaroos with bows and arrows, and also an animal which strongly resembled both a hedgehog and an ant-eater. It was like the first because it rolled itself into a ball and bristled with spines, and the second because it had sharp claws, a long slender snout which terminated in a bird's beak, and an extendable tongue covered with little thorns which served to hold the insects. "And when it is in the pot," asked Pencroft naturally, "what will it be like?" "An excellent piece of beef," replied Herbert. "We will not ask more from it," replied the sailor. During this excursion they saw several wild boars, which, however, did not offer to attack the little band, and it appeared as if they would not meet with any dangerous beasts, when, in a thick part of the wood, the reporter thought he saw, some paces from him, among the lower branches of a tree, an animal which he took for a bear, and which he very tranquilly began to draw. Happily for Gideon Spilett, the animal in question did not belong to the redoubtable family of the plantigrades. It was only a koala, better known under the name of the sloth, being about the size of a large dog, and having stiff hair of a dirty color, the paws armed with strong claws, which enabled it to climb trees and feed on the leaves. Having identified the animal, which they did not disturb, Gideon Spilett erased bear from the title of his sketch, putting koala in its place, and the journey was resumed. At 5 o'clock in the evening, Cyrus Harding gave the signal to halt. They were now outside the forest, at the beginning of the powerful spurs which supported Mount Franklin towards the west. At a distance of some 100 feet flowed the Red Creek, and consequently plenty of fresh water was within their reach. The camp was soon organized. In less than an hour, on the edge of the forest, among the trees, a hut of branches interlaced with creepers and pasted over with clay offered a tolerable shelter. Their geological researches were put off till the next day. Supper was prepared, a good fire blazed before the hut, the roast turned, and at 8 o'clock, while one of the settlers watched to keep up the fire in case any wild beasts should prowl in the neighborhood, the others slept soundly. The next day, the 21st of April, Cyrus Harding, accompanied by Herbert, went to look for the soil of ancient formation, on which he had already discovered a specimen of ore. They found the vein above ground, near the source of the creek, at the foot of one of the northeastern spurs. This ore, very rich in iron, enclosed in its fusible veinstone, was perfectly suited to the mode of reduction which the engineer intended to employ, that is, the Catalan method, but simplified, as it is used in Corsica. In fact, the Catalan method, properly so called, requires the construction of kilns and crucibles, in which the ore and the coal, placed in alternate layers, are transformed and reduced. But Cyrus Harding intended to concentrate these constructions, and wished simply to form, with the ore and the coal, a cubic mass, to the center of which he would direct the wind from his bellows. Doubtless it was the proceeding employed by Tubal-Cain, and the first metallurgist of the inhabited world. Now that which had succeeded with the grandson of Adam, and which still yielded good results in countries rich in ore and fuel, could not but succeed with the settlers in Lincoln Island. The coal, as well as the ore, was collected without trouble on the surface of the ground. They first broke the ore into little pieces, and cleansed them with the hand from the impurities which soiled their surface. Then coal and ore were arranged in heaps and in successive layers, as the charcoal burner does with the wood which he wishes to carbonize. In this way, under the influence of the air projected by the blowing machine, the coal would be transformed into carbonic acid, then into oxide of carbon, its use being to reduce the oxide of iron, that is to say, to rid it of the oxygen. Thus the engineer proceeded. The bellows of sealskin, furnished at its extremity with a nozzle of clay, which had been previously fabricated in the pottery kiln, was established near the heap of ore. Using the mechanism, which consisted of a frame, cords of fiber, and counterpoise, he threw into the mass an abundance of air, which by raising the temperature also concurred with the chemical transformation to produce in time pure iron. The operation was difficult. All the patience, all the ingenuity of the settlers was needed, but at last it succeeded, and the result was a lump of iron reduced to a spongy state, which it was necessary to shingle and faggot, that is to say, to forge so as to expel from it the liquefied veinstone. These amateur smiths had, of course, no hammer, but they were in no worse a situation than the first metallurgist, and therefore did what, no doubt, he had to do. A handle was fixed to the first lump, and was used as a hammer to forge the second on a granite anvil, and thus they obtained a coarse but useful metal. At length, after many trials and much fatigue, on the 25th of April several bars of iron were forged, and transformed into tools, crowbars, pincers, pickaxes, spades, etc., which Pencroft and Neb declared to be real jewels. But the metal was not yet in its most serviceable state, that is, of steel. Now steel is a combination of iron and coal, which is extracted either from the liquid ore, by taking from it the excess of coal, or from the iron by adding to it the coal which was wanting. The first, obtained by the decarburation of the metal, gives natural or puddled steel. The second, produced by the carburation of the iron, gives steel of cementation. It was the last which Cyrus Harding intended to forge, as he possessed iron in a pure state. He succeeded by heating the metal with powdered coal in a crucible which had previously been manufactured from clay suitable for the purpose. He then worked this steel, which is malleable both when hot or cold, with the hammer. Neb and Pencroft, cleverly directed, made hatchets, which, heated red hot, and plunged suddenly into cold water, acquired an excellent temper. Other instruments, of course roughly fashioned, were also manufactured: blades for planes, axes, hatchets, pieces of steel to be transformed into saws, chisels, then iron for spades, pickaxes, hammers, nails, etc. At last, on the 5th of May, the metallic period ended, the smiths returned to the chimneys, and new work would soon authorize them to take a fresh title. End of chapter.